folks, welcome to the NCEA Level 2 Calculus paper from 2023. So the way this video works is that I go through each question and let you guys know what you need to do for achieved merit and excellence. Now the best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering the question. So without further ado, let's get started. So with question 1a, what we've got is we've got a function and we've got to figure out when the gradient is equal to 4. So our first step is we are going to differentiate the function first. So I'm going to write down the function as it is. So then I'm going to differentiate it. When I differentiate it, I'm going to get 8x minus 12. Now the question is actually asking, find the point on the curve where the gradient is equal to where f of x is equal to 4. So we're trying to figure out the point. So we actually need x and y. So we've got to try and figure out what the x value is. So I'm going to put down, because f dash of x is equal to 4, I am going to say that 4 is equal to 8x minus 12. Let me just rewrite it like this. 8x minus 12 equals to 4. 8x is equal to 4, and bringing the minus 12 across becomes plus 12. So I'm going to get 8x is equal to 16, and then x is equal to 16 over 8, which gives me x equals to 2. But I actually need to find the point, so I need to find the y value as well. So to do that, I'm going to go back to f of x. Now remember, f of x is equal to 4x squared minus 12x. So I want to figure out what f of 2 is. So 4 times 2 squared minus 12 times 2. And I should get 16 take away 24, which gives me negative 8. So the point where the gradient is equal to positive 4, the point is 2, negative 8. So I might just do this. All I've written there is 2, negative 8 has a gradient of positive 4. So this question is actually worth an achieved, and you need to find derivative and the x coordinate found. Oh, that's interesting. Marking schedule here. As you can see, they've given the point 2, negative 8. However, for achieved, they've actually said derivative found and x coordinate found. There's not really much saying about the y coordinate, but look, they did ask for the point, so 2, negative 8 is probably what you should be doing. So that's going to get you an achieved there, but you're also going to need the gradient function as well. All right, let's go to the next question. All right, so the next question, what we've got is we've got to find the function for the gradient function. So they've actually given the gradient function, and we've got to find the original function, and this curve actually passes through 2, negative 5. So I'm going to write down the gradient function first, which is 4x cubed minus 6x squared minus 4x. I have to integrate this. So f of x is equal to 4x. Now 3 plus 1 becomes 4, divided by the new power. Then I've got minus 6x. The new power is 3, divided by 3, minus 4x squared, divided by 2. And of course, don't forget the plus c. So f of x equals x to the power of 4 minus 2x cubed minus 2x squared plus c. Now we need to figure out the actual function, so we got to figure out the c value. And the way we're going to do it is by using the 2, negative 5, because remember that 2, negative 5 basically means that x, when x is equal to 2, y is equal to minus 5. So we've got minus 5 is equal to 2 to the power of 4 minus 2 times 2 to the power of 3 minus 2 times 2 squared plus c. So 2 to the power of 4, that's going to be 16 minus 8 plus c. So we're going to get negative 5 is equal to negative 8 plus c, and then we can say that negative 8 goes to the other side to become positive 8. We've got 8 minus 5 is equal to c, so c is equal to 3. So our original function then is equal to f of x equals x to the power of 4 minus 2x cubed minus 2x squared plus 3. Grades wise, we are looking at correct antiderivative with c is achieved, sorry. So this right there is going to be worth an achieved. And then for merit, we've got correct f of x including c, so this is going to be merit. Apologies folks, I know there was a little bit of a lag between the pen and the screen, but anyway, let's get going to question C. So question C is we've got to find for this particular graph when the function is actually increasing. Now what I'm going to do is, because I've got the graphics calculator, I am going to show you what this graph actually looks like first. So we're going to go into the graph mode, and we're going to punch in this x to the power of 4. Actually, I want to get rid of this. Divided by 4 minus, wonder, can I actually do this? Oh, I can. There we go. That makes it a little bit easier. 2x to the power of 3 over 3, and then minus 12x squared plus 10. Alright, so I'm going to draw the graph. Now right now the graph actually looks like this. Alright, now you can't actually tell what's happening here. So what I'm going to do is I'm going to just see if I can zoom out a little bit. No, it's not going to let me zoom out. What if I go shift, zoom, and auto? That's not really giving me the best look. This is a total fail, isn't it? It is a total fail. Shift, zoom. What can I do? Now, as you can see, sometimes putting the graph in the calculator, you know, if you don't know what the shape looks like, it actually gets a little bit tricky. But what you can do though is I'm looking at this x to the power of 4. Now I'm particularly looking at here. It's a positive x to the power of 4, and I know that the graph actually is going to look something like a W. That much I know. Now the next thing I also know is the graph is increasing when the gradient is positive. So it's basically from this turning point to this turning point, and then from this turning point upwards. Alright, so there's actually two zones where the graph is actually increasing. So all I need to do is I need to differentiate and find out these 3 turning points. So I'm going to do that by differentiating here. I'm going to get 4x cubed over 4 minus 2 times 3x squared over 3 minus 24x plus 10 becomes 0. Now simplifying this, I've got f dash of x is equal to x cubed minus 2x squared minus 24x. Now because the 4's cancel out, the 3's cancel out. Now I've got to put the gradient is equal to 0 to figure out the turning points. So f dash of x is equal to 0 for all turning points. So I've got 0 is equal to x cubed minus 2x squared minus 24x. I'm going to factorize the x first. Take out the x, so I'm going to get x squared minus 2x minus 24. Now I'm going to factorize, simplify. Well, now I've got to factorize this, which is going to become x minus 6 and x plus 4. So my turning points are going to be at x equals to 0, x minus 6 equals to 0, so x is equal to positive 6, and x plus 4 equals to 0, which means x is equal to minus 4. So as you can see, I've got 3 points here. I've got minus 4, 0, and 6. And the parts where the gradient is actually positive is the green zone, and so you could kind of say that the function is increasing between these two zones. So you can actually say function is increasing between -4 and x and 0, and for x greater than positive 6. Alright, so looking at the answer schedule, derivative found and set equals to 0 is achieved. So right here is worth an achieved. X coordinates found is a merit. And then for an excellence, you've got to actually get the zones right. Now, having a look at the answer schedule, where is it? Here we go. So you can kind of see that justification for regions, blah, 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 where function is increasing. So as you can see, we didn't actually figure out the local max, local min, or any of those things, because we didn't really need to do that. But what we did say was we said that the function is increasing. But if you look at the schedule, they say checking gradients or graph of function or similar. Now, what we've done is we've actually provided a graph right there, and we've kind of shown them that that's where the gradient is actually increasing. Therefore, well, the gradient is positive, therefore the function is increasing. I think that should be good enough to get an excellence for you. All right, let's go to the next question. So with question D, what we've got is we've got a circle and a rectangle. All right, and the rectangle is actually inside the circle. And what we know is we've got 400 meters of running track. Basically, this border here is actually worth 400 meters. What we're trying to figure out is what's the dimensions of the rectangle. So that's this part here. We want to try and figure out what is the maximum area this rectangle could be. So let's kind of break this down, okay? So what we need to figure out first is, for the rectangle, we need the base and we need the height of the rectangle. Now, the height of the rectangle is fairly easy, because if you think about it, the height of the rectangle from here to here is the same thing as saying the circle's radius times 2. Okay, so we've got the diameter of the circle is going to be the same as the height of the rectangle, the green rectangle. So I'm gonna start working on that first. So I'm gonna put down area is equal to base times height for the rectangle, and I've got height. Now I've sorted out the height, which is 2r. So if I was to create the rectangle here, that's going to be 2r for the height, and I need to work out the base of the rectangle. Now to figure out the base of the rectangle, I've got to do 400. I've got to do 400 take away the circumference of the circle. So if you think about it like this, so the yellow part is actually worth 400. The blue part here is the circumference of the circle. So now I'll try and do that in every one of these shapes so you can kind of see it. Not there, that's the edge. So basically the circumference here is going to be the blue part, and 400 minus that. Now remember, that's going to give you the top of the rectangle and the bottom of the rectangle. So we got to actually divide this by 2 to get just one of the sides of the rectangle, because 400 is going to be the top and the bottom of the rectangle plus the circumference. So we've got to do 400, take away the circumference, but we've got to divide by 2 because we've actually got 2 sides. So when we do this, we are going to get 400, take away circumference, which is 2 pi r, divided by 2. So we can say 400 divided by 2 minus 2 pi r divided by 2, and we're going to get 200 minus pi r. So our base is equal to 200 minus pi r. Now if you think about it, when you times that by 2, you're going to get that 400 minus 2 pi r, which is this and this. All right, so just want to you folks to see that the 2 green parts is equal to 400 minus 2 pi r, but we just want one of them, which is the base, and so that's why we actually divided by 2 to get the one side. Okay, so now that we've got the base and the height, we could actually go area of the rectangle is equal to 200 minus pi r, which is the base, multiplied by h, which is 2r. So I'm going to get a is equal to 400r minus 2 pi r squared. So I need to differentiate this now. and I'm going to get a dash is equal to 400 minus 4 pi r. I know that the gradient function is equal to 0 for max or minimum. I'm going to carry on here. So 0 is equal to 400 minus 4 pi r. Rearranging it, I'm going to get 4 pi r equals 400, and the radius is equal to 400 divided by 4 pi, or r is equal to 100 over pi. Now I need to find the dimensions of the rectangle, so I've got to find the base and the height. So for rectangle, base is equal to 200 minus pi r, so I'm going to get 200 minus pi times 100 over pi, which means I'm going to get 200 minus 100. That's going to give me 100 as the base. Now the next thing I need to do is I need to figure out what the height is. So the height is equal to 2r, so that's 2 times 100 over pi, so I'm going to get 200 over pi. Now the question is actually saying find the dimensions of the rectangle that maximizes its area, which we've done, and we have to show calculus methods to show that it's a maximum. So we are going to take a dash is equal to 100 minus 4 pi r. We're going to differentiate it a second time, and we're getting minus 4 pi. And so we're going to say, since a double dash is less than 0, therefore it is maximum. Now at no point they're actually asking us to figure out what the maximum area is, but if you do want to work out the maximum area, you can, because area is equal to base times height, and we're going to get 100 times 200 over pi, which equals 20,000 over pi. So grades wise, relationship formed and differentiated, that's going to give you an achieved. I guess we're looking at achieved is somewhere around here. Merit is differentiated and values of r and x to be found. R and x to be found. I think r and base, so that's going to be merit there, and then justification is going to get you an excellence. And that's pretty much question 1, folks. We're done with that. Let's go to question 2. Alright, so question 2, what we've got is we've got a graph the derivative function. Now if you look at this looks like an upside down x to the power of 4 graph. So I'm going to write that there, minus x to the power of 4. Now that means when you differentiate this, you're going to get minus 4x cubed, roughly. That means the shape that you're going to be looking at is a cubic that looks like this. So all we're going to do is just graph the turning points, and once we get the turning points, we could actually sketch this graph. So my first turning point is somewhere around there. So there's my first turning point, and my second turning point is somewhere around here. Third one is somewhere there. So as long as my shape goes through those points, pretty much should be okay to get the grade that's required. So let's actually try and do this. So I'd want this graph to go somewhere like that, and then going through this point here, turning around and going through there, roughly. So having a look at this, basically for you to get a merit, you need a shape, you need orientation, I guess the direction of it's going, and then you've got the x-intercepts. So orientation and x-intercepts. So if you get 2 of this correct, you get achieved. If you get 3 of this correct, you get a merit. That's pretty much it for this question, folks. Now, in saying that, look, just somebody remind me this in the comment section. I'll put a link to a video that we've done before where I go through a lot of these types of questions, and it's one of those easy merit achieved questions that you can get, and they always seem to have one of this in every paper, that you have to draw the derivative function. Anyway, let's go to the next question. All right, so for the next question, what we have to do is we actually have to work out the let's show that this is a tangent to the graph of the function f of x. Okay, so we've got to figure out what the gradient, which we know what the gradient is, because gradient is equal to 8. From the gradient, we need to figure out the x value, then we figure out the y value, and then we can show that the equation is a tangent. All right, so let's kind of do that. So first step, let's work out the gradient function. It's going to be 9x squared minus 1. Now the gradient is equal to 8. The reason gradient is equal to 8 is because we can pick it up from the tangent itself. So because the gradient is equal to 8, we're going to put f dash of x equals to 8. 8 equals 9x squared minus 1. And we're going to get 9x squared is equal to 8 plus 1. So 9x squared is equal to 9. X squared is equal to 9 divided by 9. X squared is equal to 1. Therefore, x is equal to plus or minus 1. Now we need to figure out what the y values are. And because we've got f of x equals 3x cubed minus x plus 4, we're going to figure out what f of 1 and f of negative 1 is. So f of 1 is 3 cubed minus 1 plus 4. Now that's going to give us 3 minus 1 plus 4, which is 6. So the first point is 1, 6. F of negative 1 equals 3 times negative 1 cubed minus negative 1 plus 4. And for that, we're going to get negative 3 plus 1 plus 4. So we're going to get 2. So we've got negative 1 and 2. Now what we've got to do is we've actually got 2 points where the gradient is equal to 8. So now we've got to substitute in to figure out which one of these points has a tangent of 8x plus 10. So we've got to try and figure that out. So we know the gradient is equal to 8, and so we're going to do y minus y1 equals m times x minus x1, which is the equation of straight line. So we've got y minus 6 equals 8 times x minus 1. So y minus 6 is equal to 8x minus 8. Y is equal to 8x minus 8 plus 6. And our first equation is 8x minus 2. Now this is not correct, so we're not interested in this. Let's try the next one. M is equal to 8. Y minus y1, so that's going to be 2 equals m times x minus, actually I'll just write that down, write the equation down. So y minus 2 equals 8x minus negative 1. So we've got y minus 2 equals 8 times x plus 1. Y minus 2 is equal to 8x plus 8. Y minus 2 is 8x plus 8. I should take the minus 2 across, which will become a plus 2. And y is equal to 8x plus 10. So as you can see, this is the correct answer there. Y equals 8x plus 10. So it does, we have kind of shown that this is a tangent to the graph of this particular function. Now grades wise, derivative found and set to 8 gets you an achieved. Just set to 8. Wow, not even solving it. And then finally using negative 1, 2 to form the equation gets you a merit. That is what it is. We go to the next question. Alright folks, so for this question what you want to do is write down all the information that you have first. So we know that t is equal to 0. So when t is equal to 0, our velocity is 27.78, and we also have the acceleration, which is minus 2.5. Now we're trying to figure out when will the car come to a complete stop. That means we want to try and figure out when is the velocity equal to 0. What we do know is that at the beginning the velocity of the car is at 27.78. So we're going to integrate this. When we integrate acceleration, we get velocity, which is negative 2.5 t plus c. And we know that when t is equal to 0, velocity equals 27.78. So I'm going to do that. 27.78 equals negative 2.5 times 0 plus c. So c is equal to 27.78. So my velocity function is negative 2.5 t plus 27.78. Now to figure out when the velocity is equal to 0, well, let's have to put v is equal to 0 and figure out what t is. So 0 is equal to negative 2.5 t plus 27.78. Now rearranging this, I am going to get positive 2.5 t is equal to 27.78, and t is equal to 27.78 divided by 2.5, and that's going to give me 27.78 divided by 2.5. So that's going to give me about 11.11 seconds. So that's how long it's going to take for the car to come to a stop. So general expression for v found is an achieved. So this is general expression. T of 11.112 find in C1 is actually getting you a merit. Cool. Moving on to the second part of the question. Now, for the second part of this question, we're just going to kind of carry on because we've got the velocity function, which is v of t is equal to minus 2.5 t plus 27.78. Restart. Now the question is actually asking, show that the distance it takes for the car to come to a complete stop is 154. So we know something, right? From the moment he applies the brakes. So we can kind of think about it like this. When he applies the brakes at t equals to 0, we can say that the distance is equal to 0. So we're going to figure out from 0 seconds to 11.1 seconds how much distance he's actually traveled. So the first thing we're going to need is the formula for the distance. So we're going to integrate this, which means we're going to get negative 2.5 t squared over 2 plus 27.78 t plus another constant. Now, because we know that when t is equal to 0, s is equal to 0, because we're trying to measure the distance from the moment the car stopped. So because of that, we can kind of ignore c here and just write down s of t is equal to minus 2.5 t squared over 2 plus 27.78 t. Now we know that when the car comes to a stop, that's velocity equals to 0. We knew from the previous question that it was 11.112 seconds. So if we figure out s of 11.112, we should actually get about 154. 112 squared over 2 plus 27.78 times 11.112. So just a matter of putting this in the calculator. So I've got negative 2.5 multiplied by, I'm going to use the answer function here, answer squared, divided by 2 plus 27.78 times answer. And as you can see, that is giving me 154.35 meters. So it's approximately 154 meters. So we can kind of be happy with that answer there. So grades wise, we are looking at find the values of C2. Oh, this is connected to the previous question. So if you get a merit in the previous question and then you get this question correct, you pretty much get actually, yeah, you do actually. You end up getting an excellent straightforward. All right, so let's go to the next question, folks. All right, now for this question, at the end of 2023, I did a couple of speed runs and I did this question in a completely different way. And looking at the answer schedule, they've done it a different way as well. So I'm going to try and kind of explain the one in the answer schedule. So let's try this out. So the first things first, we know that acceleration is equal to 2.1. Of course, it's minus 2.1. So we're going to integrate this to get the velocity now, because what we're trying to figure out is what's the maximum speed it needed to be so that it actually stops at 154 meters, around the same distance, right? But it's got a different acceleration starting point. So things that we know is, we know that at t equals to 0, we don't know what the velocity is, because that's what we're trying trying to figure out. But what we do know is we don't know what t is, but what we do know is t, we don't know how long it's going to take, but at that point we're going to get velocity is equal to 0 and s is equal to 154 approximately. So these are some of the things that we actually know. So initially we don't know what the velocity is, but at some point the car has to come to a stop and we need to know that the distance it's traveled is 154. So based on this, we're going to try and work this out. So let's see what happens. Our first step is trying to work out the velocity function, which is negative 2.1 t plus c1. I'm going to call this c1 right now. Let's say that when t is equal to 0, now we've actually put velocity as a question mark, but let's actually say that the velocity is equal to something like k, because we don't know what that speed is. So we know that when t is equal to 0, the velocity equals k. That's that initial velocity right there. So then we can say that k is equal to negative 2.1 times 0 plus c1, which is the constant. So c1 is equal to k. Therefore, we can say that the velocity function is negative 2.1 t plus k. So all I've done there is I've just written down the velocity function with whatever the initial speed was. Now if we go back to the previous question, we did that. We're pretty much repeating the first step of this question. If you look at it, we had velocity is 27.78 and then we put v of t as negative 2.5 t right here, plus 27.78. Now we don't know what our speed is. That's why we have it as just k. Now we know that the velocity is equal to 0 at some time. So we can say that the velocity has to be 0. So that's when the car comes to a stop. We want to know what the time is. We've got the velocity function above, so we're going to put 0 is equal to negative 2.1 t plus k. Rearranging this, we're going to get 2.1 t is equal to k, or we can also say that t is equal to k divided by 2.1. So what we now have is we've actually got this t here, which is k divided by 2.1. So now what we're going to do is we're actually going to work out what the distance function is. And to do that, we have our velocity function and we're going to integrate this. So s of t is negative 2.1 t squared over 2 plus kt plus the second constant. Now we know that when t is equal to 0, so that's right at the beginning, we know that s was equal to 0, just like how we did in the first part of the question. So because of that, we can say that s of 0 is equal to 0, so 0 is equal to 0 plus c2, and we've got s of t equals negative 2.1 t squared over 2 plus kt. Now here's where things are going to get a little bit interesting, because we know that k is equal to 2.1 t. We also know that s is equal to 154 when t is equal to k over 2.1. So this is, I mean, there's two ways you can do this, and I'm going to show you the first method. Actually, I'm going to only show you one method. So we know that s of t, which is k over 2.1, is equal to 154. I hope you can see that, because that was one of the things that we actually figured out with the light blue colored. So we can say 154 equals negative 2.1 t squared. Now problem is we figured out what t is. T was k over 2.1, so that's going to be k over 2.1 squared over 2 plus k times t, which is k over 2.1. So what we've set up is we've actually set up a kind of like a really awkward looking quadratic equation, but you get the idea. So 154 is equal to negative 1.05 k squared over 2.1 squared plus k squared over 2.1. And now it's just a matter of just kind of carrying it on here. So I've got 154 equals negative 1.05 k squared over 2.1 squared. Now I've got to make the same denominator, so I'm going to put this as 2.1 k squared divided by 2.1 squared because I want to make them into the same denominators. So then I've got 154 equals negative 1.05 k squared plus 2.1 k squared divided by 2.1 squared. I'm running out of space here. So I've got 154 multiplied by 2.1 squared equals 1.05 k squared. K squared is equal to 154 times 2.1 squared divided by 1.05, and that's going to give me whatever this value is. Let's just work it out quickly. Got 154 times 2.1 squared divided by 1.05. That's 646.8, and k is equal to square root of that, which gives me 25.43 plus or minus 25.43, but we've got to choose the positive value. So car needs to be traveling at 25.43, but does it? What's the highest speed in the car should be traveling? Yeah, so the car should be traveling at 25.43 to be coming to a stop at 154 meters at a deceleration of 2.1. So crazy little question, but grades wise, general expression found is an achieved. So I guess somewhere here is an achieved. A merit is expression for T found there, and general expression for S. So you've got to do this, and you've got to do this. And then for excellence, value of K found is an excellence. Long question too, but yeah, it did stump me in the last year when I was trying to do it during the speed runs. But I think I did do it the same way in the end of the day. Yeah, 646.8. Looks like I did do the same way. Apologies about that. I thought I would have done a different way. I guess in the answer schedule they had also they substituted K as 2.1T and then put it as 154. So that's another way you could do it as well. So a couple of ways of doing this question. Anyway, folks, that's question 2 for you. All right, so let's get started with question 3A. The first question is find the gradient at the point 1,8. So we've got f of x is 2x cubed minus 9x squared plus 12x plus 3. F dash of x 6x squared minus 18x plus 12. Now we need to find the gradient at 1. So we've got 16 times 1 minus 18 times 1 plus 12. And that's going to give us a gradient of 0. Part 2 of this question. Now I think this one here is worth derivative found and correct gradient is worth and achieved. Going to the second part of the question. Find the coordinates of another point on the curve that has the same gradient as in part 1. So we've got to find another coordinates of the point. So we know that 6x squared, the gradient function is this. So our gradient function is 6x squared minus 18x plus 12. And we know that the gradient was actually equal to 0. So now we're trying to figure out another point. So we're going to put 0 is equal to 6x squared minus 18x plus 12. Common factor of 6, x squared minus 3x plus 2. Factorize this. We're going to get x minus 2, x minus 1. Therefore, x minus 2 equals to 0, x minus 1 equals to 0. So we've got our two values, x equals to 2 and x equals to 1. Now, in the previous question, we already had 1,8. So we just need to figure out what the y value for 2 is. So we're going to take f of x, which was 2x cubed minus 9x squared plus 12x plus 3. That's basically from the question above. We just need to work out the y value for when x equals to 2. So that's 2 times 2 cubed, 2 squared, 12 times 2 plus 3. And putting this all in the calculator, oh no, I always make this minus 9 times 4 plus, and that's going to give us 7. So the other point is going to be 2, 7 has gradient of 0. All right, next question. Now grades wise, correct gradient equation equal to 0. That gets you and coordinates found as a merit. So it's one of those weird double questions where you have to get part 1 and part 2 correct. All right, so for the next question, we're looking at rate of increase of followers on day 5. So we're basically looking for f dash and then restart and then substitute 5 as the time. So first we work out f dash of t. That's going to be 15t squared minus 1680t plus 42,180. So f dash of 5 is 15 times 5 squared minus 1680 times 5 plus 42,180. Putting this in the calculator, 15 times 25, we're going to get 34,155, and this actually gets you an achieved grade. On to the next question. We've got, what is the maximum number of followers during the first 90 days? So I guess we got to put the gradient is equal to 0 and figure out the two values and then go from there. So the gradient function is, what was it? 15t squared minus 1680t plus 42,180. So for max or min to happen is equal to 0. So we've got 0 equals 15t squared minus 1680t plus 42,180. I'm putting this in the calculator. So let's go into menu, go into equation, polynomial, degree 2. We've got 15 minus 1680t, 42,180. Solving this, I'm getting 74 and 38. So t is equal to 38 and 74. And if you think about the original graph that we had, the original graph was a cubic, so it looks like this, which means our maximum is going to be there and our minimum, local max and local minimum, is going to be there. And because the way time is structured, we can see that that is equal to 38 and that's equal to 74. So we need to figure out what the followers were on the 38 when t is equal to 38. That's going to give us the number of followers they have. So we're going to go back and get the original equation, which is that 5t cubed 840t squared equation. 5t cubed minus 840t squared plus 42,180t. So f of 38 is 5 times 38 cubed minus 840 38 squared and plus 42,180 times 38. So put that all in the calculator. All right, so that comes out to be 664,240. Now, in terms of, you could actually find the minimum as well. Like you could actually go f of 74 to kind of prove that f of 38 is the maximum. So what I might just do is I'm going to go back and just get rid of all the 38s and replace it with 74. And one more. So that's going to give me 547,600. So as you can see, that will then tell us that we've basically got the maximum happens at f of 38. So we can actually say that is a max, while f of 74 is a minimum. Now grades wise, we are looking at derivative set to 0. So it's kind of like one of those follow-up questions. We had to get part 1 correct, or you could have got a part 2. You're going to get a merit for this part. For the achieved part is actually putting it equal to 0. All right, so let's go to part 3. For how many days during 90 days does a social media account lose followers? Now, really interesting, because we've kind of already did that in the previous question, because in the previous question we figured out that it was a cubic, and we can also see that the followers is decreasing between 38 and 74. So what you could actually say here is, for it to lose followers, we want to say that f dash of t has to be less than 0. So in other words, we know the equation for the f dash of t, because that was the 15t squared right at the top there when we differentiated it. So we can say 15t squared minus 1680t plus 42,180 has to be less than 0. Now this particular graph is a parabola, and we already found the two intercept points there, because that was 38 and that was 74. And for when it's less than 0, it is between these two zones here. So I guess we would say it's losing followers between 38, when t is between 38 to 74. So the question's asking how many days during the first 90 days. So you probably have to go 74 take away 38. 74 take away 38. That's going to give you 36 days of losing followers. Justifying decreasing region. Well, see, like, I want to show you guys the answer here. Now they've actually said that we've got 36 days. They worked out negative and positive, local negatives and positive, which you could do that. But we've actually justified the decreasing region by showing it by the graph there. So I reckon we should be okay with that to get an excellence grade. All right, final question for the day. Now, once again, folks, in the speedrun, I actually did this a different way. So in this one, I'm going to try and do a different way. So let's try and do this, all right? So what we've got is we've got a gradient function, has a tangent at x equals to 4, and also crosses the curve at 0, -7. Love it. So I guess the first thing I want to kind of point out is that it has a tangent at x equals to 4, but it crosses the curve at, the tangent crosses the curve at 0, -7. So if it crosses at 0, -7, I'm going to use this y minus y1 equals m times x minus x1. I don't know what the gradient is, but what I do know is I've got negative y minus -7 equals, I don't know what the gradient is, but I do know it's going through 0. So I've got y plus 7 equals mx, or y is equal to mx minus 7. Now, I can work out what the y value, and so I know that x is equal to 4 here, but before that, hang on. But I need the y value for x equals to 4, and I also need the gradient at x equals to 4, because that's where the tangent is at. So I need f of 4, and I also need f dash of 4. So to do f of 4, I've got 4 cubed minus p times 4 squared plus 21 times 4 minus 7. So f of 4 is going to be whatever this nasty looking thing here is. So if I was to do that, 4 cubed is 64, not worried about that, plus 84 minus 7. That's going to give me 141 minus 16p. Then I'm going to work out f dash of x, which is 3x squared minus 2px plus 21. And I'm going to find the gradient when x equals to 4. So that's going to be 3 times 4 squared minus 2p times 4 plus 21. So I've got 4 squared is 16, 48, 48 plus 21 is 69 minus 8p. Okay, so I mean, that's actually not too bad, because I've got the gradient, I've got the y value. So if you think about it like this, I'm going to rewrite this as y minus y1 equals m times x minus x1. So the x1 value is 4, which is that. The y1 value, which happens to be the f of 4, actually no, let me just show you here. So I'm actually taking f of 4, which is the same thing as y value at 4. Then the gradient happens to be the m value, which is this part here, 69 minus 8p. So putting this all together, I'm going to get y minus 141, put that in a bracket, minus 16p equals 69 minus 8p times, I have a feeling I'm doing something wrong here. Yes, I am doing something wrong here. Why am I doing that? But the problem with this one is that I'm going to end up with an equation, right? But what I need to do is I probably need to use the y equals mx minus 7. So let's actually use that. So I shouldn't be using this one. Instead, I'm going to use y equals mx minus 7 because I already have all of these things. I've got m, I've got x, and I've got y. So really, I shouldn't have been using this one because that's just going to complicate things. So y is equal to 141 minus 16p equals 69 minus 8p times x minus 7. So expanding the brackets, 141 minus 16p equals 69x minus 8p. Now x is equal to 4, so I don't know why I'm doing that. Times it by 4. So we got 69 times 4, which is, what have we got? 200 and minus 7. $276 minus 32p minus 7. So we're going to get 141 minus 16p equals 269 minus 32p, bringing the 32p across here. 32p minus 16p equals 269 minus 141. So I've got 16p equals 269 minus 141 gives you 128, which then gives me p is equal to 128 divided by 16, which is equal to 8. Yeah, I shouldn't have done that middle step there. I think I was just way too tired to kind of just keep doing silly things, and that would have actually, you know, what I did in the previous line in here, that would have just ended up with y equals mx minus 7 in a more complex way than I needed to be. So anyway, folks, grades wise, we're looking at derivative found in expression, tangent found in terms of p. Okay, so this is going to be achieved right here. Formed tangent equation of both expressions for the gradient of tangent found, both expressions for the gradient. I'm not understanding what that is, but the last part is worth an excellence. Like, I'm looking at here, formed tangent equation. Oh, I guess, yeah, okay, fine. I guess we did do this part to get a merit. So we would be up to here to actually get a merit, and then solving it would actually be giving us an excellence. That's a pretty interesting question, because I think I did that differently in the speed run. Looks like the light's out. Dawn. All right, folks. Overall, it wasn't actually too bad of a paper. I do apologize. I know my throat was killing me this morning, and I had to kind of clear my throat a few times. But look, if you have any feedback for this particular paper, leave it in the comment section below. If you want to see any other questions done differently, again, let me know in the comment section, and I'll try and get it done. Now, we are going to be doing a level 2 calculus in 15 hours playlist at some point. I'm hoping to do it in term 3 of 2024. And let's see how that goes. But yeah, as for this paper, it was all right. One big kind of favor from me is that as we move into the future, would love for you to just show your support by subscribing to this channel, and of course switch off all the notifications, because I know I make a lot of random stuff and you probably don't need to see every single one of them. Anyway, all the best for your exams as well.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.